So we have 1 minute before the meeting is scheduled to begin. So I cannot imagine a more exciting way to spend a Saturday morning. Let me actually do this. My clock is just ticked over to 6 a.m. Ted, please give me a verbal thumbs up or thumbs down that we are ready to begin on your end.
All right, well, I believe we are actually ready. They're going to close the door, so you can get started. And from a logistical perspective in the room here, if you have questions or anything, just shout them out. I will relay them to Matthew.
I have a slide for this, so let's actually put that one on hold. So let me say hello to everyone. So it's good morning here, but good afternoon to everyone in Stockholm. To get things started, I want to emphasize how important and valuable it is for sponsors for community organized events like SQL Saturdays. You cannot make an event like this happen without support from sponsors. The organizers are key, but the sponsors are as well. So please visit them and say thank you. I also want to emphasize how much I really, really wanted to be in Stockholm today. Stockholm is my favorite city in the world, whether it is for the lions or for the dragons, whether it is for the Nordic Museum or for Junibakken. The food, even after my favorite restaurant in the world closed last year. I don't know if you ever made it to Esperanto while it was still there. There's amazing food, amazing people. And even though my recent trips to Sweden have taken me more to Gothenburg, that is primarily because they have the better swordplay events. Sweden will always have, or Stockholm will always have, a true metal place in my heart, because this is the first place that I ever got a bass string from Joey DeMaio at a Manowar concert. But with all of that said, I will not be in Stockholm today. I haven't shared the details yet, but essentially, I failed to book flights for this event. When I was talking with the organizers 2 or 2.5 months ago, I looked at the plane tickets. Airfare was great. I said, yes, I will definitely be there. And I remember booking tickets, but I don't trust that memory because I don't have any tickets to be there. So if you do have any questions, what I will ask is that you open your laptop, open your phone, drop them into Twitter. So my Twitter handle is at SQL Allfather. And if you ask me a question on Twitter during the event, I will answer that question immediately after this session is done. And if you ask me a question later on, if you've got other things to do, I will do my best to answer that later today, Redmond time. So this is sort of the introduction. I'm rushing a little bit because I've got so much content that I'm interested in going through today, and I know that an hour is not a lot of time. From an introductory perspective, I am a program manager on the Microsoft Power BI team. I have been working at Microsoft for around 10.5 years at this point. Before joining Microsoft, I spent 10 to 15 years primarily as a data warehousing and database and ETL consultant. So the topics and the capabilities around data flows have really been near and dear to my heart for most of my professional career. And when I think about data flows in Power BI, I think about them in 3 ways. Each one of these introductions, each one of these ways of looking at data flows shows an aspect of how they add capabilities into Power BI and ways that they can be used. Since this is not an introductory session, I'm not going to spend as much time on this as I otherwise might, but I am going to go through this because I believe it's important to lay the foundation for the demos and for the Azure integration details to come. So the first way that I think about data flows in Power BI is that they are part of an evolution of the self-service BI platform. I've been doing data stuff long enough to remember when it was really cool and exciting to have a database to work with. You know, your client would have an application, you know, their first PC sort of thing. There's a file-based database with the information behind it. And even though each application had its own silo of data and typically would have some built-in reporting capabilities, clients would want new visualizations. So they would want reports or dashboards or other ways to get insights that the application developer didn't include. And as the use of customers and the use of computers and automated systems got greater, we had more of these transactional systems, and the need was to have the reports and the dashboards and other visualizations include data from more than one system, which caused the need for the data warehouse pattern to emerge. And when I say data warehouse, most professionals will immediately think of a cloud data warehouse or relational data warehouse. In this context, think about the capabilities, not the technology. The technology could be a relational database. It could be an underlying data lake with files and folders. But this pattern solves a common, well-understood set of problems with capabilities around staging, around having a location for the consolidation and preparation, cleansing, and standardization of data from multiple sources so that you can have a single point of access for downstream analysis and other processing. So when we had that data warehouse introduced into our pattern, this introduced the need. And Ted, are you trying to jump in with a question?
No.
Okay. So I just want to be attentive. If you do have a question, just speak my name loudly, and I will not listen to the smaller sounds. So
the only thing I would suggest, Matthew, if you could, is
yes,
move
sir.
the mic away from your lip just a little bit.
Is that a better audio?
I think so.
Excellent.
Yes, everybody in the room is agreeing.
Thank you for that. And if there's anything else that I'm doing that is similarly annoying, definitely do speak up, because I will do my best to adjust. So here we have as the data warehouse pattern or architectural tier was introduced, came with it the need for data preparation or ETL. This is the logic to get the data from all of those transactional sources and to reshape it and load it into that central place. And of course, once we had all of this data in a more analytics-friendly location and format, we ended up having more and more users wanting to do more and more things. And at this point, the platform or the industry evolved to include a greater performing architectural component with OLAP in-memory analytics models. So this could be a cube, this could be a tabular model. And what we're looking at here is a generic way to visualize what BI systems looked like 20 years ago. So there's nothing in here that's new. What's been new in the last 10 to 15 years, maybe a little bit less than that, is the evolution of self-service capabilities in business intelligence. So we have tools like Power BI, like Tableau, ClickView, MicroStrategy, whatever tool you choose. The goal of self-service BI is to reduce the load on the IT team, to let the data professionals do more strategic things, while at the same time enabling the business professionals, the people that need to get insights from data, to be more agile and more responsive and not to be blocked by IT. Most self-service BI tools will focus on the visualization side of things. So self-service reporting, self-service dashboarding, and Power BI has always included both a self-service modeling, so the data sets that you create in Power BI desktop, and it's always included as well the self-service data preparation through Power Query. But the challenge with Power Query, as we have traditionally used it, is that the queries that we define in our self-service data preparation layer are defining the tables in our analytics model. That means that any logic that is defined here is trapped here in a useful location, but one that is not useful for reuse. So in this context, this way of introducing Power BI data flows are a way to bridge this gap and to use the same the same self-service data preparation capabilities through Power Query to load that data into a location where it can then be shared and reused for multiple users in multiple analytics models and downstream contexts in a self-service BI context without requiring explicit IT involvement. So it bridges that gap for self-service business intelligence. The second way that I want to introduce Power BI data flows is that they are another object type or artifact type inside of the Power BI service. So if you've used Power BI, you're familiar with creating reports and dashboards, and you know that you need to create a data set, the underlying tabular model for your reports and dashboards to use. This is still the same thing. Data flows do not replace data sets. What data flows do is they serve as another possible data source type on which you can build your data sets. Data flows are fully managed by the Power BI service, so that when a user is connecting to data from Power BI desktop, they have data flows as another data source type, and they can mash up data flow data with SQL or Oracle or whatever other data they need. An interesting analogy here is that while data sets in the Power BI service are simply analysis services tabular models that are managed by the service, data flows are CDM folders, which is a data storage format we'll go into more depth on later, but they're these folders of data that are physically stored in Azure storage behind the scenes, but they are also fully managed by the Power BI service. Just as your Power BI users never know that they're creating a tabular model, they'll also never know that they're creating files and folders in Azure storage when they create a data flow. But we're applying the same patterns here, building these self-service capabilities on top of the mature underlying data platforms that we've developed. The third way that I want to introduce Power BI data flows is to say that Power BI data flows are like Excel. If you think about how Excel works, a given cell in an Excel workbook contains references to other cells or ranges of cells in that workbook or other workbooks. And because Excel formulas are a functional language, so essentially each one of these defines a function that references another, and at some point references data that is entered directly and not a function. Each one of these functions understands its lineage and its dependencies, and it has the Excel process as an execution context to track all of this. Now, we take for granted that Excel works like this. We've been using spreadsheets for decades, and we understand, instinctively at this point, we understand how they work. If you've ever done enterprise ETL, if you've worked on an enterprise data warehouse project, you know really deeply that this is not how enterprise ETL tools work. For enterprise ETL tools, you have to develop packages, whatever your noun is. You have to develop packages, and then you need to orchestrate them to ensure that the right things run in the right ways, and that transactional consistency is maintained, so that if one thing fails, another thing doesn't start, or if one thing runs long, the other thing doesn't start until it's completed. Now, Power BI data flows are like Excel because every entity in a Power BI data flow is defined by its function. Now, I haven't introduced any terms yet because this is not an introductory session, but let me just say that if you think about a data flow as being a container, like a database is a container, that's a great way to think about it here. So in this diagram, we have a data flow called ingest from dynamic sales or sales staging or whatever we want to call it. And it has 22 entities in it. This is kind of like a database with 22 tables, but each one of these entities is defined by a Power Query query. And this Power Query is a function that when executed populates the data in the entity, but like an Excel formula, it's a single authoritative function that says, get data from here, do these things with it, put the value in this location. And if we look at this diagram, where on the left we have sources that are external to the Power BI service, this layer, the staging layer, is where we're bringing the data into Power BI. these data flows need to be explicitly refreshed. So someone needs to click refresh now or set up a refresh schedule or manage this programmatically. But when these are refreshed and the data in these entities is updated, because Power BI understands the relationships between all of the data flows in the service, when these are ready, these downstream data flows that in turn pull data from other data flows inside the service, they will automatically refresh in a transactionally consistent manner so that without any explicit user action being taken, simply by building these data flows that represent our star schema and having them based on these data flows that are that represent our cleansed and enriched data, which in turn were based on these data flows which represent our staged data, the entire orchestration simply works because of the relationships, because of that authoritative lineage information that the Power BI service maintains. Now, enough talking. Let's actually look to see what this looks like as we're building a data flow end to end. So from a demo perspective, I'm going to move over here and I'm going to start with a blank workspace. I created the workspace before the session began, and I'm going to build up 3 different data flows to show a canonical or regular example of how we see data flows being used. I have a set of URLs that are on a screen that I'm not sharing. So if you see my mouse moving away, that is because I am copying, I'm cheating to get my URLs from my text file. And for this first data flow, I'm going to pull in data about promotions that my organization is running. I have this data stored in a set of text files in Azure storage. I'm going to do some basic transformation on it. You'll notice that the experience here is based in Power Query Online, so it's a very familiar experience for Power BI users. It's in a new location, but it's the same Power Query experience that we know and love. And I'm going to do some basic transformations. So I have added, or I've promoted headers. I'm going to split this particular column because we've got multiple values that are in it that are delimited. So I've got this nice end-to-end table or entity that I've defined. I will give this a name. Call it promotions. And notice as well, if I right-click on this and choose Advanced Editor, I have the same Power Query, the same underlying language, and the same connectivity stack that we use in other parts of Power BI. And this opens up all sorts of capabilities, but this is where the Excel-like nature of Power BI data flows comes in, because that Power Query is the formula that defines all of where the data comes from and how it's transformed. I'm going to save this data flow, and I'm going to call it promotions staging, just using this to pull the data into the system. So we are good there. I am going to create, and I will refresh this as well, so I'm immediately prompted to either refresh or to set up a schedule. While this is refreshing, I am going to create a second data flow. Again, I'm going to pull in new entities by getting data from outside of the system. For this one, I am going to pull in data from a SQL Server database. That I am pulling in data only from cloud sources today. This is not because that's a limitation of data flows. It's simply because it is easier for me to set up and run a demo without needing local or on-prem resources. But you can use the same gateways that you would use in other parts of Power BI. For this one, or for this particular data flow, I'm going to pull in 3 entities from SQL Server tables. I'm not going to do any transformation, but I'll give this one a more meaningful name. Choose Save and Close again. Once we're done with the validation, we will put in a name. We will refresh the second data flow. Remember that data flows are like databases. So each one of these is a container that has multiple entities inside it. The next thing that I want to do is I want to take these two staging data flows and I want to bring them together. So I want to use data that I've pulled in from one and data that I've pulled in from another to create data flows that combine data from these various sources. I could combine these directly, but there's very common situations where a data source has a load window due to the timing of transactional load. Or there are other considerations that would say these get refreshed at this time, these get refreshed at this time, and having different data flows with different refresh schedules allows us to easily handle this type of pattern. For this third data flow, I'm actually using Power BI data flows as my source. And when I go through this second path, I can see all of the workspaces in my Power BI tenant that I have access to that contain data flows that I can use as sources. And down here, I will pull in data from the accounts and calls staging data flow that I've just created. And I will pull in data from this promotions staging data flow that I've just created. And you'll notice that these are in the same workspace that my current data flow is in, but this is not a limitation of data flows. I can also pull in information. So let's say that in addition to the promotion data and the calls data that I've just pulled in here, I also have existing data flow in a different workspace that another user has created where I can pull in information about products and customers and their addresses. And when I choose next, let me just click on these guys to get all of the icons to load. So when I click next, you will notice that each one of these entities that I've created are linked entities. So there's a little chain link icon that is displayed next to them. What we have done here is we have just created a pointer to where the data already lives. We're not duplicating it. We're not copying it. We're simply saying, let's create a new starting point by referencing this other data source. And once I've done this, I can use this in all of the ways that you would expect. So here I will say I'm going to combine tables by merging queries to create a new one. So I will have promotions on the left. I will have calls by account by day on the right. I'll choose account ID as the column that I'm going to join on. Choose OK. I will scroll over here to the right. We'll expand out this by day, make our little changes here. We'll choose OK. And now I have a data flow entity that pulls data from multiple other data flows, does transformations, and presents them in a consistent way. When I choose Save and Close here, the validation is going to take a little bit longer because I have a larger number of entities to validate. But once this is done, we'll have this. We'll put in our name. And for this one, I am not going to save, or sorry, I'm not going to refresh when I save. What I instead want to do is to demonstrate what it is that we've created so far before we bring this back into the context of Azure. So as I close out my third data flow, you'll notice that back in my workspace, I have this original promotion staging data flow. I have this accounts and calls staging data flow, and then I have the data flows that pulls in information from them. As I move, and notice as well that one of them has not yet been refreshed. As I move from the list view to our relationship view, we can see both the relationship between the data flows that I've created today and this other data flow, this AdventureWorks data flow that I've pulled in that staging data for customers and addresses. And when I enable data sources, and let me zoom out just a little bit here so we can see the entire thing, we can see how that lineage information that the Power BI service automatically maintains is represented graphically, where we have the sources that are outside of the system. we have the sources that are inside the system, either in our current workspace or outside of it. And then we have that downstream, data flow that contains the data from all of these. And this visual view gives us an easy way to understand relationships and dependencies and impact. And when I refresh any of these upstream data flows, so if I click on the action button and choose refresh now, you'll notice the refresh starts to spin here. And as soon as when this refresh is at a point where the downstream refresh can begin, it will begin automatically. So let me zoom back in and hope that we can see this a little better. But if I come in to look at the refresh history for this, you'll notice that we have two different on-demand refreshes. So you watch me do each of these. One was when I created the data flow, and one was right now. If I look at the third data flow and I look at the refresh history, I can is only one. And instead of saying on demand for the type, it has linked source as the refresh type, letting us as the workspace admin know that that this refresh was triggered by the underlying, the upstream data flows and the dependencies, the underlying dependencies in the service. So everything that I've done here is defining entities of data that are stored as CDM folders in Azure under the hood. Let's actually take a look from what we've just done from a self-service BI capability and look at more of the details about how this actually interacts with Azure and what are the scenarios that enables. Let me emphasize here that everything that I have done from a demo perspective today is something that an analyst can do in Power BI. We're simply using Power Query in the browser to connect to a source, to do transformations, and to save them. So this is a new experience, but it's a familiar set of tools. What's really interesting and exciting is the underlying integration with Azure Data Lake Storage Gen 2 that enables more scenarios for reuse. So if we think about what we just did here, we created a Power BI data flow that defines the ingestion logic to store data in a CDM folder or a set of CDM folders. Now, a CDM folder is just a set of files and folders in a data lake with a specific format, but it is designed to enable integration between multiple services, both cloud services from Microsoft and from you and from third parties. And if we think about the simple scenario, Power BI can write to and read from the CDM folders that it creates. And other Azure services that handle data ingest, like Azure Data Factory, can also read and write to Azure Data Lake Storage and can create and consume CDM folders. And from a strategic perspective, this CDM standard, this technology, is a big bet that Microsoft Cloud and Enterprise Group, so this includes all of Azure, all of Power BI, all of Dynamics, all of Power Apps and Flow, and so on. So this is a significant bet that all cloud data services at Microsoft are investing in to enable simple integration between these services. So even though Power BI and Data Factory are the two primary ingress services, all other Azure data services will be reading and writing from CDM folders to support their workloads, so that a CDM folder that is created by an analyst as a Power BI data flow could serve without any integration code needing to be written, without any transformation or thunking. They can be used as a data source for Azure machine learning models, or for Databricks, or for other downstream processing. And it's also worth emphasizing that Power BI has other integration paths with these other Azure services too, but CDM folders are a primary mechanism for data exchange. Now, if you've used data flows in Power BI, you have probably noticed that the CDM folders that you are creating are not available for other Azure services to consume. the default setup is that the Power BI service uses its own built-in storage, so it's still Azure behind the scenes, but it is an Azure storage account that is fully managed by Power BI, which means that the Power BI service is the only writer and it's the only reader. This is great for enabling self-service collaboration and allowing one analyst to create things for other analysts to consume in Power BI, or enabling a central IT team, like part of your BI Center of Excellence, to create data flows that are reusable by analysts inside of Power BI. But if you actually want to enable this full integration scenario, there are explicit steps that you need to take to set this up. So there are 3 basic paths that you need to go through in order to enable this Azure Data Lake integration in Power BI. The first path, which is shown by the first swim lane up here, is a one-time configuration step where a Power BI global administrator needs to create and configure an Azure storage account. I'm not going to go through all of the requirements here because it's basically a bunch of fiddly, pedantic things, and because we're going to make that experience much easier before the Azure integration, which is currently in preview, is generally available. So this configuration is step intensive today, but it's also well documented. We're going to make it much more simple and user friendly by the time that we go GA. But we'll create an Azure storage account. We'll configure it as an ADLS Gen 2 account. We will assign specific permissions to it so that the Power BI service can read and manage the data that's in it. And then we will also attach that storage account to Power BI. This is a one-time configuration at the tenant level in the Power BI Admin Center. And it's also important to emphasize that during preview, this is configurable once so that there is a single Azure storage account that is used by the entire Power BI tenant, making it so that there is more granular control so that, for example, you can have multiple storage accounts configured at the tenant level, and then at the workspace level, you can choose which one to use. This is something that's on our backlog, but it's not available in preview today. So we do that one-time step to say we've attached this storage to our Power BI tenant, and the administrator can then say, I will enable workspace administrators to use this storage account. So this is saying Power BI knows where the storage is, and then there is an explicit switch to say, yes, we can use that account. Once this is done, this means that workspace administrators, when they create a new workspace, they will be able to assign that workspace to the organizational data lake account. This is a per workspace option. The default is to use the built-in Power BI storage, but a workspace administrator can choose something other than the default. The second swim, yes, sir.
We have a question in the room here. If you could just spend a moment and discuss the capabilities as they apply to standard capacity versus premium capacity.
That is an awesome question, and thank you very much for asking it. I have a slide all the way at the end that touches on this a little bit, but since we only have an hour, I may or may not speak to that slide. So there's 2 ways to answer. So the first one is for everything related to Azure integration. So all of the things that we're looking at right now, none of these depend on premium capacity. If you're using shared capacity, you can still integrate in with your own organizational account, and you can still attach external CDM folders, which is the other flow that we'll show later on. So none of the Azure integration requires Power BI Premium, full stop. Another way to answer is that there are 2 capabilities in Power BI data flows that require Power BI Premium today. One of them is the composable ETL, so that Excel-like automatically refresh when the other things refresh. That does require Premium. The second thing that requires premium is incremental refresh of data flow entities. But everything else with data flows will work with shared capacity as well. Does that answer the question, Ted?
Yes, it does. Thank you.
Excellent. And thank you for the question, and thank you for jumping in. So let's look at that second swim lane. In that second swim lane, once the tenant configuration has been completed, when a workspace administrator creates a new workspace, just as they can choose to put that workspace, they have the option to put it on a premium capacity. They will also have the option to turn on the switch to use the organizational data lake account. Once this is done, when they have created and refreshed their data flows, or refreshing it is key because that's when the data actually gets produced. When this flow is done, there is now a CDM folder, so a folder full of files of data that exists in that data lake storage account for others to consume. So when the two swim lanes in Power BI are completed, now we can move on to this third swim lane, which is enabling a developer or data scientist or data engineer to use that data in Azure. So here, the first thing that they need to do is to be aware that CDM folder exists. They need to connect to it, and they need to have authorization to connect to it. But this is essentially a data discovery and connection problem. It's no longer a real technical problem. And when this is done, we now have an end-to-end experience where, as Power BI is writing to this CDM folder through the refresh of data flows, every Azure service that is consuming it can now have access to that data, even though it's being produced by a self-service BI process. So let's jump back in to our demo environment, and let's look at some of the additional things that we've done for the demo that we already completed. So you notice that I already had a workspace created to start with. In order for me to do this demo, beforehand, I had configured, let me do this. So my Zoom, it doesn't want to work, so I'm going to assume that you guys can read what's on the screen. But here in my admin portal, since I'm a tenant administrator for this particular demo environment, under data flow settings, I have configured this preview feature to enable Power BI to write to this specific data lake storage account. So this storage account has been set up. It's had the right permission set so that Power BI can do what it needs to do. This is that first swim lane that we looked at in that slide. The second one is we have allowed workspace administrators to assign their workspaces to the storage account. So this fulfills the two requirements to be done for that first line. The second thing, let's go back to our default Zoom. The second thing that we've done is in our workspace settings. So we're back in the workspace. I've come up to settings. Even though I had premium turned on so that the composable ETL, those linked entities would work, that wasn't required for our Azure integration. What was required was turning on this data flow storage. And you'll notice that it's coming up and saying data flow storage can't be changed because there are already data flows in it. Because there is no capability to move data between your organizational account and the built-in storage, this setting can only be changed for a new workspace or for a workspace that does not yet have any data flows defined. And another aspect of this is that the linked and computed entities capability, remember how I emphasized, we're not copying the data, we're not duplicating it, et cetera, et cetera. A side effect of this is that the ability to have these relationships between data flows in different workspaces, both workspaces must be in the same storage account in order for linked and computed entities to work. So for our Azure integration setup, we set our tenant settings, we set our workspace settings, and we created and refreshed our actual data flows. What happened behind the scenes? So let me pull Azure Storage Explorer down here. So we'll make this a little bit bigger. make it a little bit smaller. So Azure Storage Explorer is a free UI tool for working with storage accounts in Azure. And I will use this to look at this subscription. So I've got this pay-as-you-go subscription that I use for this demo. And if I expand out this account, and you'll notice that this is the same storage account that we saw configured in Power BI. If I expand this out, we have a blob container inside, or sorry, we have our blob containers node, and inside this we have a blob container that is called Power BI. This is where all of our workspaces that are configured to use this storage account will put their CDM folders. And as I select this and I scroll down over here, we can see that there is this SQL Saturday Stockholm demo. All of these other folders are folders or parent folders for the different workspaces that are created. Power BI automatically defines this folder structure. So if I double click into my workspace, I can see the 3 different data flows that I'd created. And each one of these is a CDM folder, common data model folder, which means that it will contain 2 different things. It's going to contain a model.json file. This model.json file contains all of the metadata for all of the entities in this data flow and for the data flow itself. And the CDM folder also contains a set of CSV files for each of the entities that are in that data flow. So here you'll notice, I guess there are a couple things to call out. One is that we have a folder structure that includes snapshots in its name, and we have a CSV file, but it also has a snapshot and a timestamp on it for the data. And you may also notice that even though in this final data flow that we created, there were like 7 or 8 entities, but there's only 1 entity that's stored here. This is because the actual data for those other entities still lives in the storage location where it was originally created. We're only referencing. And the snapshots is important because of the need for transactional consistency. If you think about what would happen when a reader, whether it's someone in Power BI Desktop or a data set refresh that's taking place or another data flow that is referencing one of these data flow entities, if someone is reading from a data flow entity and that entity is being refreshed at the same time, there needs to be a way for both of those operations to complete without transactional consistency being violated. Power BI data flows actually use the same logic and much of the same code as the snapshotting mechanism inside of analysis services to handle these similar patterns as well. So we will have, and actually I'm going to come up here, back up to my workspace folder. I will come down into promotions to look at some of the additional details here. So notice for this one, because of the refreshes that I've done on this workflow, I've done more things with it. In addition to our model.json, we have snapshots for that. And if we come down into promotions, we can see the snapshots for the entity as well. So moving back into Power BI, I actually want to look at some underlying JSON that's being created because this is kind of significant. And I will choose the action item here and choose export JSON. I could do this from inside of Azure Storage Explorer as well and get the exact same file, but I like to do it from Power BI because it just the UX flow is a little bit easier. So I end up with a JSON file. Let me pretty format this, and let's look at some of the information that's inside it. The reason that this is important is because the CDM folder format defines an explicit required schema for all of the entities that are inside it. So some of these are going to be Power BI specific, but much of it is going to be general to any CDM folder that is being created or consumed by any Azure service. So this JSON file defines our accounts and calls staging data flow. And it will allow us to see both basic metadata like the name, the description, the version, the last time that it was modified. It will allow us to see what is the M package, the underlying mashup that Power BI used to load the data. So this metadata is essentially saying we've got these 3 different entities and they're referencing these queries by ID and these are the names of them. This is the same sort of metadata that would be defined in any Power Query environment. And if you look down here, this document attribute contains the full Power Query scripts for all of the entities that exist. If we move further down, we can see that we have 3 different entities. So we've got a local entity called accounts, and inside it we have all of these different attributes. And the interesting and perhaps most important thing is that we have this partitions section that will define the partitioning policy. And this is just a full refresh because there is no incremental refresh. The last time that it was refreshed and the full URL to the file that's being referenced. If we had set up incremental refresh, we would have a list of partitions here that matches to whatever refresh policy we've defined based on the history of this entity. Coming back into the Power BI UI, I'm going to export the JSON for our final downstream data flow as well, just so that we can see some of the differences here. Again, we'll wait for this to load. We'll pretty format it. Let me do a quick search. So when we get down into the entities here, because this CDM folder does not contain all of the data for all of the entities that it defines, what we instead have is a set of reference entities that will call out the name, the source, and the location of all of the entities that are physically stored in another location, but which are logically exposed as entities in this data flow. So essentially creating the data flows through the Power BI Power Query online experience will allow us to automatically, the service does all of the heavy lifting, define both the logical definition of the CDM folders in these model.json files and also define and maintain the data that's being produced through the execution of those queries.
Hey,
yes, sir.
Before you continue on, I have another question here in the room. I'm going to let him ask it if we can hopefully do that here.
I'm picturing the in-room logistics. So thank you everyone for understanding my airline failure.
Sorry, I got a quick question. Is there a plan, or do you know a plan from an Azure analysis services perspective to be able to start or load these or export these to analysis services models or Tableau models?
So let me answer that question in 2 different ways. So the first thing is, until an upcoming capability is published in our business applications release notes, which is our public roadmap, I am not allowed to discuss it publicly. I can only discuss it under NDA. So I cannot answer that question today. But what I can say is that all of the Azure services, even ones that I'm not explicitly mentioning here, are invested in this CDM folder format to use it as a data source or a data destination, depending on their capabilities. And Azure Analysis Services literally shares the same code base as Power BI and Power BI Premium. Not all of the code is enabled for all deployments, but this is a very logical future direction that aligns with our priorities. So,
thank you very much.
Okay, thank you. Hopefully my not answering your question gives you the information you need. So there's one additional path for Azure integration that I want to show before I jump back into my slides. We do have just over 10 minutes left. So you've noticed, or you may have noticed, I copied the URL to this model.json file. So I went into properties, I copied that URL out. What I can do here, let me come back to my list view. So here I have the 3 data flows that are defined in Power BI. I want to add a 4th data flow to this workspace, but what I want to do is to choose this final option, which is attach a CDM folder. This is known as an external CDM folder or external data flow, where I simply put in a name and a description and paste in the URL to the model.json file that defines a CDM folder in Azure. And when I say create and attach, there's no definition. Power BI doesn't have any logic behind this. And we go out of our way in the workspace view to say, this is an external data flow. You know, look, there's less information, there's fewer options. What this gives us the ability to do is to have some other Azure service writing to the CDM folder and managing and maintaining the data while still making it available as a fully managed self-service data source for Power BI consumers. So if we jump back, into the demo, let me actually come back here to show this. This is the path where we have data coming in from another service, writing into CDM folders in Azure, and then making that available for this low-code, no-code experience inside of Power BI. Now, I've talked about CDM folders and the common data model a lot, but I haven't actually defined anything. And it's worth spending some time at the end of the hour. Now that we've seen some of the end-to-end capabilities and some of the details, let's talk about some of the concepts that are important to understand as you move forward to use this later on when you get back to the office when it's not Saturday anymore. So the common data model is a metadata standard. So the text on the slide, I literally copied and pasted from our documentation. So the CDM is a metadata system that is designed to enable structural and semantic consistency across multiple applications and deployments. I like to think of it as a platform and tool agnostic version of the system tables or the system catalog in SQL Server. So this is sys.objects and sys.columns and sys.types, but in a way that any application can use it. The reason that I think that it's really important to talk about the fact that the common data model is a metadata system is because most people don't think of it this way, and it's Microsoft's fault that they don't. When Microsoft first announced the common data model, the second definition is what we led with. We're telling people, oh, the common data model is this set of pre-built business entities. We've got account and campaign and product and all these different things. And it's awesome because everybody can use the same definition of all of these things. And this is really true. The common data model is also this, but at its root, the common data model is a metadata standard. And Microsoft has built a set of standardized extensible schemas using that standard. And we're working with industry partners and third parties to build out additional sets of entities for things like healthcare and retail and manufacturing. But at its root, the thing that is most generally useful today is the fact that it's a metadata standard. And how about CDM folders or common data model folders? A CDM folder is simply a folder in a lake that conforms to a specific well-defined structure and schema that conforms with that common data model standard. So if the common data model is a metadata format, CDM folders are a data persistence format that uses CDM metadata. And there are 2 different types of content that you will see in every CDM folder. The first one is a model.json file. It has to be named that. It must be model.json, and it must be at the root of the folder. This makes discovery incredibly simple. And then there's a set of data files. They have to be CSV today. We are going to support Parquet as our next file format, and it's likely that Avro will be the 3rd format that we support. But as of whatever month and year, oh, it's May the 4th, 2019. As of today, CSV is the only format that we support. but because these are standard files that everyone can read and write, very easy to use. The way that it's set up is we have some sort of file system level, typically managed by the applications that are writing it. We have a set of folders with that model.json and with the data files inside it. Power BI has a specific set of subfolders. That's optional, but it's nice. It makes it more manageable. And the reason that I ask these questions, the reason I'm saying, what about CDM? What about CDM folders and all these things, is that this is really the magic of Power BI data flows. Those CDM folders are the magic glue that allows Power BI and Azure and other Azure services, even if you're not using Power BI, it enables all of these integration formats for both business analysts. This is really the key. We've got the low code, no code experience, and we have the pro code, mo code experience over here, the low to high code experience. What makes it possible for them to work together is CDM folders in Azure Data Lake. We've got 5 minutes left. I want to wrap up with some less technical things. I want to emphasize here, and this is not specific to Azure, but these are common questions that I hear. This is kind of an FAQ. When you think about Power BI data flows, do not think about replacing other tools. Don't think about replacing Data Factory or integration services. That's not what we're trying to do. What we are trying to do is we are trying to enable business users, Power Query users, and analysts to do things that they used to need to go to IT to do. So it's all about self-service data preparation, closing a self-service gap, not being a new enterprise ETL tool. And the other way, and we're kind of restating things here, but another thing that is key to understand as well is that when you don't have data flows, we invariably see our business users either having to wait for IT or working around IT by dumping things to Excel or CSV files or the like, or we see organizations that are investing in third-party tools like Alteryx or Datamir or the like, which often tend to be expensive and don't integrate in well. Data flows close these gaps. And what I believe is my final slide before I wrap things up, the type of customer production scenario that we see. And we've got customers that have been using data flows in production even before data flows went GA. But what we generally see is a set of data flows that have been created by a central team. This may be an IT team or it may be a business team. Most frequently, it is a BI center of excellence inside a large organization that uses both IT and business resources, but they're using Power BI data flows to both stage data and to do cleansing, and in this case, calculations is how we call it out on the slide. But we get the data into the system and do common things to it, and this is done by a central group, and then from this point on, some specific line of business, so some set of consumers with a specific and smaller scope, they will use this as a source. They will filter it, they will transform it, they will add other data sources to it, and then they'll build their data sets and visualizations on top of it. And this part of the diagram scales out horizontally as well. So there may be dozens of different lines of business that are using this data flow as one of their sources. So having this data flow as a composable unit of data that multiple internal groups can consume and work with and so on, this is both what data flows were designed to do, and it's the pattern that we see customers implementing with data flows. I will share these slides. These will be on my blog either today or tomorrow, and I'll tweet the link out. But there's a ton of information on data flows and the Azure integration that's available. My favorite resource is this end-to-end partner sample, which basically walks you through starting with an Azure trial subscription to create and consume CDM folders from multiple Azure services. I also need to do the shameless plug for my blog. I've been blogging for about 6 months on dataflows. There's a ton of information that's out there. I honestly think that this is the best single online resource for Power BI dataflows information. You can choose to agree or disagree on that one, but the best thing to do, if you have questions following this session, ask Ted because he knows everything, or find me on Twitter. If you've asked the question, if you ask it within the next 10 minutes or so, I will answer it right away. And if you ask it later in the weekend, I'll answer it as quickly as possible. So with no further ado, we've got 1 minute left. Ted, do we have one question, or do we give everybody the extra 1 minute break in between?
From the looks of everybody, they're smiling and laughing about the extra 1 minute.
Yeah, well, it's Saturday morning. It's the day.
Wait, we do have a question.
I can't drink
it's that guy.
There you go.
And I could not hear what the gentleman said.
He was talking about the water that's on my desk.
All right. Well, I will say thank you very much to everyone. The next time that there's an opportunity to be in Sweden, I will definitely be on it. So thank you very much for both joining me and for understanding the special accommodations. And thank you to Ted for making this work.
Well, thank you, Matthew. It worked out very well.
All righty. Take care, everyone. Have a great day.
Sorry.